Is Professor Christine G, and I'm going to be going over these inequalities. So first of all, this question came in, and we have this equation, and we can see it was nicely simplified to y equals 1x or x plus 0 because we subtract 6 off of both sides, and then we're left with 4x, and this goes to 0, is less than, and then this would be negative 4y. So then the next thing that we're going to do is go ahead and let's divide both sides. We want to get a y. Typically we get y on the left-hand side. So why don't we go ahead and we'll move y over here and we'll move x over there. So if we add 4y to both sides, then we have 4y is less than 4x. But that 4x, when we move it over, we take negative 4x off of both sides. So this has to be negative. So then I divide both sides by 4. And then this cancels, and I'm just left with 4 divided by 4 is 1. 1 times y is y is less than, and then negative 4 divided by 4 is negative 1. And typically we write that as negative x, but it's implied that there's a 1 here. So y is less than negative x. So we can look at an inequality by graphing the it's not going to be equal to, so it's going to be a dotted line, but we can get points for the dotted line by doing an XY table. And by XY table, we can just put in any value, yes, any value that we want to for x, and then get a corresponding value for y. So if x is 0, we could use 100, but we want to be easy on ourselves. So if x is 0, then y is 0. Okay, so that is actually the y-intercept. And then if we put in 1 for x, well, y, if we're looking at this as y equals negative x, because we're looking at a line first, and then we're going to dot the line. So if we substitute 1 in for x, then we get negative 1 for y. Okay, so now I have 2 points. I have all that I need in order to graph. Let me see. My line's not going to be, no, I don't even want to play around with the line tool in here. I'll just go like this. And then this is always the y-axis, and then this is always the x-axis. And then here we have this point. Let me change the color. And we're going to use blue for that, but the point 0, 0, so that was easy enough. And then the point where x is 1, so we're going over 1, and then y is negative 1. Oh, it should have been maybe up here a little bit more. Okay, and so now we know, and that makes sense, our line is going, and because it doesn't equal, it's a dotted line. So the solution is not on this line. Okay, it's either to the right or the left. But notice the line is going downhill. That means it's negative slope, and we know that from here. This is in the y-intercept form with our slope being in front of x. So here, now we need to know, where do we shade? Well, y is less than negative x. So what we can do is, let's go ahead and pick a point over on this side. Let's just say this is the point 3, 3, where x is 3 and y is 3. Okay, and let's see if it's true. If it's true, then we're going to shade this side. If it's not, we're going to shade the other side. So here, if y is 3, so our equation is y is less than negative x. So as if y is 3, is that less than negative 3? Nope, it's not. So we are going to shade the other side, but we could pick a point here and we could try like the point -1, -1, and see if, oh, sorry. We have the point where x is -1 and y is -1. Would that be true? So then what we do is we go ahead and we substitute in. So here's our inequality, and we substitute in y is -1 and x is -1. Well, -1 is a positive 1. So we know that this side would be shaded. Okay, we tested that out. You only have to test one point, but for the point of the video, I wanted to illustrate that. So this would be, so everything, all these points to the left of this line would be solution points. So now let's go ahead and take a look at this equation, and might run out of room. So I'm going to clear this out so I have plenty of room. Okay, so on this one, okay, so here we can see right away, if we add 9y to both sides, it's going to go to 0. So then we're just left with, I'm going to write it up here, 3x is greater than 15. So now all we have to do is solve for x, and then we get, oh, greater than or equal to, sorry about that. And then we divide this, and those cancel, and so we're left with x is greater than or equal to 15 divided by 3 is 5. Okay, so now guess what? If we were looking at this, just like we looked at this equation when we were graphing it, when we were looking at y is less than -x. Well, what we did was we really said y equals -x to get the points on the graph, but we were going to have a dotted line. Well, in this case, it's actually equal to, so we're going to be able to graph that, and it will be a solid line because on that line, those are going to be solution points. Okay, so we can set up our XY table. And when x is 0, what is y going to be? And, oh, I did that the wrong way. I should have said, we're looking at, the equation that we're looking at is x equals 5, okay? And we're going to get points for that equation. Well, x equals 5. What does y equal? Well, y can equal any number because no matter what y is, x is always going to be 5. So y could be 1, x, no matter what, is going to be 5. So then let's say y is 0. Okay, so now we have 2 points, and we can go to graph. Okay, so here again is our x-axis, and then here is our y-axis. And let's see, I'm going to do a different color. Hopefully that doesn't mess this up. Okay, and so 1, 2, 3, 4, 5. So when x is 5, y is 1. And when x is 5, y is 0. So we also have that point. And guess what? 2 points determine a line. So no matter what y is, x is always going to be 5. And then we look at this equation, or this inequality, and we also know that there's solutions that are greater than 5. So so x greater than or equal to 5, well, if x is 6, so x is 6, is that greater than or equal to 5? Yes, that checks out. So we would go ahead and shade this side of the graph. Hope that makes sense, and if you have any questions, please feel free to email me anytime. Thanks so much. Have a great day. Appreciate you watching.